Hello, folks. I am Abhik and I am back with another episode of the Stupid CS Guy. In this interview, we have called on another member of the community, a senior engineer, to build another system. So, this system that we will be building today is Twitter. Now, because it's a senior person who is come into the episode, the problem statement will be more abstract and the questions will go a lot deeper. I think you are expected to know a lot more about the system that you are building. Some of the questions can go into uh, partitioning, some of the questions can go into the availability of the system that you are building, and then data replication and all of that. So the questions format are going to be the same, but it's just the depth that you require when you are going for a senior engineer interview is different from an SDE1 interview or an SDE2 interview. Like I said, today we will be building Twitter and we will jump right into the interview now. Okay, starting recording. So today the interview question is to build a system like Twitter where user can share content, other users can follow that person, the user can follow other person, and when the user logs in, they'll be able to see a feed of content and whatnot. So that's the interview question.
So a system like Twitter. So if I think about the core functionalities, it should be like user is sharing content. So what type of content we are talking about? It will be text and
As you see, John has started asking a lot of questions, and that is really, really good. That is important so that the interviewer and you are on the same page.
or say we call this tweet. So user is posting tweet which can consist of text and images. So images means there can be multiple images. Okay.
Yeah.
And there might be some limitation on the text size that user is publishing, right?
Yeah, we'll do 140 characters.
And if you think about other functionality, user is profile management, which means user will have some profile details. And user will be following people, other users, or say other users. Okay, now another core functionality will be feed, right? The Twitter feed. So each user will be according to each user. So a feed will be based on the persons which I am following.
Yeah.
Based on users which followed. Will there be any other type of feed, for example, feeds not coming from the persons who is being followed? Something like latest news or according to the user's interest, or do you think we can just limit for now?
Yeah, let's leave it to users being followed.
Okay. And I guess the feed will be latest on top. on top. Okay, so if I talk about the core functionalities, now we can deduce what type of data we will be persisting, and then accordingly we can divide these into different small functionalities which each service can handle, and then we will target about how we will design those services. In terms of scaling, we have to keep in mind, I assume we have to keep in mind about scaling it to, I would say, 1 million of users. Okay.
Yeah.
So let's think about what are the persistence layers should.
So John has started working on the persistence layer part of the interview. I'm not a huge fan of this. I believe before jumping into the persistence layer, we should do the constraints of the system. We should talk about the APIs that the system should expose. Then we should do the estimation. And then only we should jump into the persistence layer. Having those ready will be very easy for you to convince that why are you going for a SQL based system or why are you going for a NoSQL based system. Without that, jumping into the persistence layer seems a
Data is different.
Mm.
So we are not assuming that we have search functionalities and all, but it will be good. I think it will be good if we can design in a way in which we can also search the tweets. For now, we are not. Are we thinking about hashtags, or do you think it's something we can skip?
That's a good point. Now, as a senior engineer, you are expected to come up with features and come up with designs which are more future proof. And that is exactly what John is doing. While he's building the system, he's thinking of what other features that I can add. And he recommended that, hey, can we design a system where we can already have hashtag search? And hence, then I said that, hey, let's add that to the requirement. And this product thinking is also something that you will be judged on.
Hashtags search will be only from the users which I am following, or it can be from anywhere in the world.
It could be all public tweets as well as the users you are following.
Okay. Okay. So that's good. Okay.
Actually, let's limit to all
Now.
public tweets. Yeah, we'll keep it simple. Just say all public tweets.
And in the persistence layer, tweets of users we will be saving text and images, and now we will have to save users followers. Okay, so which will be the users which I will be following, or a particular user following which user. So okay, apart from that, we need to have a way where we can have tweets indexed based on hashtags. So hashtag based indexes of tweets. Okay, so as I think about different type of data that we are storing, uh, uh, for simplicity, I can start with user profile data. For this, user profile consists of username and a few other details, including image, user profile image. I think this for now we can like store in any database, which we can scale horizontally based on the user ID shard, based on user ID. So if we have to add multiple, if users are being added more than say million, we should be able to add more
So
system
you're partitioning data based on.
user ID.
Okay.
So scalable, I would say based on user ID.
So
So
what in the persistence layer, what database are you using?
yeah, so yeah, I am coming to that.
Hmm.
Um, for user, see the type of data which we are handling, I don't think it is kind of transactional data, and any kind of no schema based database will be good. Especially for user profile, I think any type of data which will give me good read access or a good read latencies, that will be good. We can have any kind of noise NoSQL type of database. We can use also MongoDB for this,
Hmm.
and we can have a caching layer on top of it
Yeah.
for making it fast. So I would say for now, let's select MongoDB for this, and this will help us also in case if we want to change our schema or if we add more properties to user.
Okay.
Okay. Now for tweets of users, text and images, and for profile image, we will have a basically we need to have an image server. Image server will have um, say something like S3 type of AWS S3 type of file system where images are stored and which can be served, as well as there can be background processes or jobs which will have image processing functionalities, processing back.
So John is kind of mixing up the persistence layer with the system design. I would generally recommend to just focus on the persistence layer, talk about the various database, and go into in depth. Like, say, hey, here is the primary key, here is the metadata, here is the other few important things that we will store in the database. You need to be a little less abstract, and not say that, hey, here's the sort of data that we'll use. So while you're designing the persistence layer, just focus on the data. Don't talk about background pipeline, because there's a separate time for that, and that's the actual system design part, which will come next.
User, what are the some of the important properties of tweets? Tweets will have properties. Tweets will have post user ID. Tweets will have content. It can have hashtags.
Yeah.
And what else? Time of posting.
Yeah, it'll have some metadata.
Correct. Some other metadata. Uh, so again, I would say that since tweet is something that will need a separate, that will need a dedicated backend, so that we can have scale it differently, scale it differently, and we can have the background jobs running on tweets for doing further processing. I would say that the database layer or the persistence layer, uh, instance-wise, it should be different from profile data. We can use any NoSQL database, and partitioning again we can do based on user ID. Uh, if we are doing partitioning based on user ID, this will help us to get all the tweets uh,
Hmm.
from a user, and Some challenges, like again, the assumption is, say, there will not be millions of tweets from a user. Say, even if a
Hmm.
person is doing.
The thing about I liked about this part is how John is spending the effort to talk about his partitioning strategy. Partitioning is a very important part of system design, and the more senior role that you go to, the more would be the stress for partitioning. He's talking about why did he choose user ID as partitioning, what was he thinking about, and in general, walking me through his thought process. So that is something great. We should always do. Walk the interviewer through your thought process, especially when it comes to partitioning.
2 or 3 tweets per day, it
Mhm.
will be still in a year, it will be still in thousands.
Okay.
So we don't think that even if we do sharding by user ID. And again, for this case, I would say I am thinking of two type of database that we can use. Uh,
Mhm.
One can be Cassandra, another can be MongoDB.
Okay.
Cassandra is no column database, and it's there are some advantages over MongoDB on Cassandra.
What are those advantages?
Yeah, so Cassandra, if you see, it's no master kind of database in a distributed system. It works in a ring-based topology, and we can add as many, and there is no single point of failure in terms
Mhm.
of maintenance of DB. In terms of adding columns, and in terms of adding more metadata for a particular tweet, it will be more beneficial because again, it's in schema-less database. For MongoDB, it's like a JSON that we are storing for a particular ID. Whereas it's more systematic in term in it's more systematic when we talk about Cassandra, in a way that we have at least the columns which we can get, and we can add more columns. We can have indexes on columns, multiple columns in
Yeah.
Cassandra.
Mhm.
So
So can the so I'm curious of why don't you put the user profile data in Cassandra also?
mhm.
Or do you
the
think user access? Now this is an important part here. John uses MongoDB to store the user profile data, and then he uses Cassandra to store the tweets. Now, with the X versus Y database does not really matter. What I'm trying to understand is the constraints of the system. Now, if you remember that MongoDB is an CP system and Cassandra is a AP system. That is what I'm trying to hear out. Why did he choose a CP system and then he moved to an AP system? Try and use those terms. This tells the interviewer that you know what you're talking about. The interviewer is not really worried about the exact database you are using. As long as you say, hey, you know what? For this, I am looking for a CP system and a DB. For this part, I'm looking for an AP system and a columnar DB. So that is what you should use to channel the discussion and not really worry about saying, hey, X is a better DB than Y, because that is very abstract. Different.
So from my what I think is in Cassandra, in MongoDB, particularly in user profile, the access pattern, and in terms of tweets, the access pattern is little different. If you see tweet, we are adding the data and we will be reading it mostly. Uh, at most, the update that will happen on a tweet will be we will be deleting the tweet.
Mhm.
And if we think like, again, this is, I am making an assumption that we will not be updating a tweet.
Huge props to John for talking about the access patterns. When you are designing a NoSQL system, make sure you talk about access patterns. Access patterns are what will guide you towards the appropriate database schema. If you're designing a NoSQL system, you don't talk about access pattern, it just won't work.
So, okay. So MongoDB is a CP system, and then
Mm-hmm.
Cassandra is an AP system.
Mm-hmm.
So I'm trying to understand, why did you like optimize for availability in the user profile data section? As in, why did you don't you want availability more than consistency?
In case of, if we see in terms of user profile data,
Hmm.
I would say for a user profile data, the updates will happen and consistency is required. For tweets of a user,
Hmm.
for tweets of a user, I would say the availability is required more.
Hmm.
And they will we are assuming that for a single tweet, updates will be less. If we assume that there are background jobs who are updating or adding metadata for tweets,
Hmm.
in that case we will have we will have like tweets which are getting updated with their metadata by the background jobs.
Hmm.
But apart from that, I think availability for tweets will be more required because it will be more like a read based system.
Hmm. I see. That's fair.
Okay. So yeah, so that's what I am thinking as of now.
Okay.
That yeah, and when we are trying to save user followers, so in this case, when we are saving user followers, when we are saving user followers, I would say um, we need to access all the user followers, get the user IDs, get all the tweets of the users of those IDs, and arrange it in a sequence of the time of posting.
Hmm.
Okay,
Hmm.
and yeah, so I would say we can store it in the same user profile, in a user profile DB in a separate schema.
Okay.
So
So still still
so that
still partitioned by user ID.
uh, I
Now, as senior engineers, you could expect to have these kind of discussions, talk about AP versus CP, talk about your partitioning strategy, talk about how the access patterns are different between two sorts of data and how that changes your decisions.
say that since the data access is based on a particular user, I would say that we can have it partition based on user ID.
I see. So based on this, I can, so let's say if I'm saying that get followers for a user ID, this is going to
Mm-hmm.
easily give that to me. Um,
Yes.
what if I want to say people who follow me? That's like followers and followings, right? So you want to see
Mm-hmm. Correct.
how will you get that?
Mm-hmm. Yeah. Let me think about it. So yes, that is something that we will have to solve for. So, for example, We can have a two-way schema also. What I'm thinking at high level is either we can do redundancy, which means I am also saving the people whom I am following, and I am also saving who my followers are. But with redundancy, that can lead to inconsistency, because whenever any change happen, I will have to update at two places. So I think that should need a better design, which can help me find out both the details in a quick manner. Okay, so
Now, this is an interesting part. We need to show the list of followers, and the way John is doing it, he's partitioning it based on the user ID. But then, if you really think about Twitter or Instagram, you want to see people who are following you. You also want to see users who you are following, which is called, the followers of a user, the followings of a user. Now, with this mechanism, we would have to do a cross-partition query. And that is what I called out, saying, hey, if you're partitioning like this, you'll have to do cross-partition queries. You'll have to fan out across all the partitions. How will you solve that? Now, this I would hold it against John, because one way to make sure that you don't miss these is to write the APIs. So before the persistence layer, you have one section which calls out APIs, and you say APIs get followers for a user, get followings for a user. The moment you write those APIs, you now know the access pattern that I might need to get the followers of a user. I also need to get who the user is following without doing like full scan queries. And that's an important thing to remember.
Let's simplify this a little more. Let's say we are okay with some redundancy of the data.
In case of if we are okay with some redundancy of data, in that case, what we can do is we save user ID to followed users mapping. And whenever someone follows me, okay, followers, whenever someone follows me, I will have that data updated in my for me as well. So followers will have a user ID, like a friend's ID. So if we store it in this way, it will have redundancy, but I think in terms of retrieval, it will be fast.
John is spending quite an amount of time talking about trade-offs. Now, this is really, really good. As a senior engineer, you should talk about trade-offs. No system is perfect. Now, here, because we want to get the followers and the followings, there are a couple of options. We can do scan queries, which is very, very compute heavy. And if there's a lot of data, it might not even complete. You can normalize the data and store it separately. Again, it makes it compute heavy because now you would need to do an application join and whatnot. Or you can denormalize the data and store it in the database. Always remember that the storage is cheap, compute is costly. And that is what John is going with. He's saying that, hey, we'll denormalize the data, but then we have a trade-off between we will take more storage, but the retrieval will be really, really fast. And that's what he's speaking through.
I am following someone. This data also gets updated, the people whom I am following. In my followers database or in my followers schema, my ID also gets updated in followers to user ID mapping. So that also gets updated.
Yeah. Okay.
I think this will make sense. This we can do.
Yep. Okay, that makes sense.
In terms of hashtag-based tweets, yeah. So whenever we are storing tweets in our database, and we have some hashtags, and since we are using a database which can have multiple attributes or multiple hashtags added to it. So we need to have, so both way mapping we need to have tweet to tweet ID to hashtags. And hashtags to tweet ID. So, yeah.
What is the system that you're using? You're creating it in database?
Yeah. So, let me think about it. So basically, if we are mapping hashtags to a tweet ID, when this will happen, whenever I am doing a tweet, the tweets get saved in my tweet database with a particular user ID, which is sorted by a particular user ID.
Yeah.
And its attributes with tweet ID to hashtags get saved in tweet database. Okay. Which, and similarly, for those hashtags which are present in those tweets, we need to have another update mechanism where we will have hashtags versus tweet ID. So that also will have a many-to-many relationship. Hashtags can have multiple tweet IDs. Either we can use, and in this case, if you see, it will be read and write heavy operation. So write in terms of update, what I was thinking is it should not be in terms of updating a particular hashtag. Okay. It should be in terms of adding a row for a hashtag. So for example, one example can be hashtag, say India will have tweet ID 1, hashtag India. If someone else makes a...
So if you are asked to design a search, string-based search, the best thing is to go with Elasticsearch and not really design a search algorithm yourselves. You can say that, hey, I just want to use Elasticsearch and I have used it briefly. This is what are the internals of Elasticsearch, and leave it at that. Not everybody has designed a search system, and it is completely okay to say that, hey, I've not designed it, but I do know that Elasticsearch can be used, and this is how it generally works. It tells the interviewer that you know about the platform. It is just that you have not used it, which is absolutely.
Obviously, the hashtags will grow very large, and how we will partition it and based on tweet ID. So basically, we are not updating or keeping a map of, we are not doing like this 1, 2, 3.
Okay.
But rather we are adding each row for each hashtag. So yes.
What's data store here?
Yeah, let me think about it. So what I am thinking is, if we have to scale it, we can use something like a hashing based on tags. And for now, I can think of using an RDBMS, but even for like if we use RDBMS or any NoSQL database, that will have, suppose if we use NoSQL database, something like Cassandra, have another schema which has tweet ID, tweet hashtags versus tweet ID. That also we can use. This will have sharding based on based on hashing of hashtags, I mean tags.
I see.
So this will help us. Suppose if in the UI, if I click on a particular hashtag, it should immediately give me a list of tweet IDs, and those tweet IDs, if I give it to, if I query by those tweet IDs, immediately I will get all the tweets which I can render. Whenever I am, whenever someone is doing a tweet with some hashtags, those hashtags are also saved in the tweet database as well as in that schema, as well as we take the tags, hashtags from that and the tweet ID which gets saved, and we also update the hashtag table with the tweet ID to hashtag mapping.
Okay.
Okay. Okay, so in case if we have to apply searching and background jobs which run on the tweets, we can also have like other schemas which update metadata on the tweets and have metadata to tweet mapping similarly.
Sure. Okay. Let's go into the system design now.
Okay. So I would say this is a user.
Yeah.
And what user does immediately, and I will try to design in a way where we have interaction with the system, and then how the services they will be consuming the database, or they will be hitting the database. I will also try to divide it into sub processes, or you can say core services. So let's say we have the user is using, say this is a client browser, and then browser hits my authentication layer. So user logs in, and user logs in the browser, and all the calls from the browser goes to a middleware. We can assume, say, or we say that middleware empty or middle tier. So so all those things, it can be browser, it can be mobile, it going through a middle tier, and middle tier internally consumes a host of services. So let's assume that this is the block which consumes our services. Okay, where we have multiple services. Now let's say we have a profile management service, user profile service.
So isn't your middle tier a single point of failure?
So it depends on how we are designing the middle tier. If we go deep into the middle tier, so middle tier itself will be based on some system. For example, if we say that our middle tier is based on Node.js and it's exposing the data through a GraphQL, we will have our...
Now, John has started off with his system design. And the key aspect of system design is load balancer, which he has missed. Make sure you do not miss the load balancer part. That is really important. Not only saying the load balancer, also saying what type of load balancer, whether it's a layer 4 and layer 7, and reasoning why are you using a layer 4 or a layer 7 load balancer would go a long way in telling your interviewer that you really know system design.
So let's say we have a user profile service, and let's assume that all the calls go through an authentication layer. So this is the authentication layer through which all the call goes, and we have Tweet service, the responsibility of tweet service will be whenever we are searching for any tweet, whenever we are searching for, whenever we are doing any tweet, or whenever we are searching for tweet, the tweet service will have that responsibility. And then we will have a image service. As you know that in high level, this is what I think. There will be other services, but I think this should be the core of our system. And this should be auth layer. Auth layer can be based on JWT. Okay. And whenever the user is authenticated for a particular call, the call goes to individual services, and middle tier will be calling individual services, getting the data and returning it to the client.
I see. Okay.
Okay, so now if we see, user profile service will be talking to our user DB, which will be Mongo DB.
Yeah.
And we will have a tweet DB, and tweet service will be talking to it.
Yeah.
And we will have a S3, or you can say image server. Yeah. And a image service will be returning and doing on the fly if any image modifications are required or not. And now I can like come to what are the technologies, or like for a given service, what are the different technologies.
Small pro tip here. If you are going for draw IO, make sure you are familiar with the tools. So for example, if you see in the next part, John will start drawing outside of that big box that he drew. Try and avoid big boxes. Big boxes are limiting. That means if you have to make changes to your system, now you'll have to increase that box, otherwise it will look odd and you'll be overflowing that box and whatnot. Generally, keep it open-ended. Make sure that in Draw IO, you uncheck the page view so that you have the entire canvas to yourself. You don't want to be limited with the page length and whatnot. So that's something that you should practice. The more you practice, you will know these tools well.
Compute layer of the services.
Yeah.
Okay. So we can use multiple orchestrator platform. One of the platform which I have worked on is using Docker and Kubernetes cluster.
So here John starts talking about orchestrator platforms like Docker and Kubernetes. I believe that's a level of detail that you do not need to go in a system design interview. If you have time to talk about those, feel free to talk about those. But for this interview, I would rather want John to talk about asynchronous messaging systems. Like what happens when you upload an image? Do we resize the image? Do we have separate copies of the image? Do we have run sort of filter on the tweets? Those are the things, and building extra features are something that he could concentrate on rather than talking about a lower level orchestration details. Try and remain at a higher abstraction and not go into that lower level of details.
The user profile service is a CP, so it's not much of a problem. In tweet service, will there be any case where you did a tweet and then you refresh the page, and in your list of tweets, that tweet is not there?
So yeah, so that can happen. Suppose whenever someone has deleted a particular tweet, it might be possible that that tweet got deleted. And definitely this tweet service needs to respond very fast.
No, the tweet did not get deleted, let's say, because it's it's an AP system, right? So that means
because
can there be a
consistency,
yeah.
there can be a consistency issue.
Now, as senior engineers, you would expect questions like this, saying that how do we get read after write consistency in an AP system? You should be able to understand that in an AP system, there are trade-offs that you will be making, and how do you deal with those trade-offs? Uh, One answer that could be here is saying that, hey, we are already partitioning by user ID. So there's a high chance that the user's request is going to end up in the same data center, in that same partition. And even if there are like 4 replicas in the partition, the replication lag is going to be within few milliseconds. We should be fine. Now, the next question could be, what if this lands up in a data center which is away from the user? Let's say the first request went to data center 1, the second request went to data center 2. How would you do that? What would be the replication like? So there can be questions about that, and that is what John tries.
Well, it depends on how the tweet service is talking to the tweet database. Suppose for a tweet service, when I say all my followers, give me all my followers, and give me a list of all the tweets for a particular follower. Definitely, we will be making call to the tweet DB with the user ID partition. So, like I got like 100 or 200 users, and for those users, I am calling the tweet database. So what will happen in that case? Whenever I am getting the tweets, it may happen that some of the calls, if we are making a sequential call, which means either for all the users, I gave it to database at once, and then I make a call where I say that give me users for, or give me tweets for all these users in the last like 1 hour, and return me all the tweets. In that case, it may happen that some of the calls which I have made for some particular users may fail for tweet database.
Yeah.
So this is one scenario which I think, in which case the tweet service, there might be some cases where the tweet gets lost while rendering.
I see. Okay.
Apart from that, the other logic which will be there in the tweet service will be how we will how we are arranging the tweets, how we are talking to tweet DB in a particular way, and other logics in which we are updating the tweet and getting tweets by a particular hashtag ID, like searching for tweets.
I see. How will the feed generation work?
Yeah. So let's say, yeah. So this is a tweet service. For the feed generation, what will happen? First step will be get user followers, which will be itself a list of user ID. How the tweet service will know? It will call the user service, and it can call the user service, and it will get it from there, the list of all the, it will get the list of all the followers.
Yeah.
Okay. And once we have all the followers, the tweet service, what tweet service will have to do is, it has to get the tweets from the DB. It has to get all the tweets from the DB for those particular user IDs. So if we see, yeah. So if we see the call which is being made, something like for tweets of all the user IDs. So it will try to get all the tweets for a particular user ID. a list of user ID. So it should return me a list of tweets. Now the part here is there can be multiple tweets for a particular user ID, right? Definitely in the feed, we want to return only the latest tweets, right? So for that, what we will have to do is we'll have to arrange all the tweets in the descending order or limit the tweets. So for example, the tweet service should respond in a paginated way, right? For to the browser. It should have that capacity of returning in a paginated way. So it is returning to the empty or
So if
browser.
I follow, remember I told you why we should not draw big bounding rectangles on top of your system design? This is the exact reason. So what John did was he put some system design on top. He had to put a bounding rectangle, but there was no space. He had to go down again and mostly replicate that diagram because he ran out of space. So try and avoid that. Make sure you are familiar with the tools before the D-Day. And when the D-Day comes, you use the same tools that you are familiar with. Generally, companies use Google Whiteboard, or my favorite is Draw.io. So that brings us to the end of the interview. The interview went well. There were some gaps that we spoke about. System design was still new to John. He's still practicing, but overall, his concepts as a software engineer are all spot on. He spoke about APCP systems. He spoke about trade-offs. He spoke about read after write consistency. He spoke about how his databases choices would differ. So he hit all of the right points. It is just that he now needs to practice and come up with a format that he can stick to. Of course, couple of misses, like there were not a list of APIs. There was no talk about constraints. There was no estimations done. And that is why you need more practice, even if you have been system designing in your regular job. Let me know in the comments what else you would like to see. If you like this video, don't forget to like, share, and subscribe. And please follow me at LinkedIn for more content on system design.